So what is 6 mod 5?
It's 1.
Okay, so where do you think might be the key to finding the number 6 in our set? Where do you think is going to be the key?
Well, maybe if you found like a large power of 6, like 1296.
Okay. Now, all right, you're right. We might, if we found 1296, which is 36 times 36.
Yep.
1296. So annoyed with this marker. Would go to 36, which would go to 6.
Yep.
But we don't know 1296, right? What do we know? What do we know that's mod? That's 1 mod 5 in the
We
set?
know 2916.
We know 2916.
But we can't
And
really.
we don't know how to go
subtract.
down, unfortunately.
Yeah.
Well, we can go back then. We can go to 54. That's about as far as we can go.
Right, but from 54, we unfortunately don't get up to 1296.
Yeah.
And by the way, going down by 5s from 2916 doesn't get you to 54. All right, so we have a plan of how we could get to 6.
Well, couldn't you go down?
If we started at 1296, but that unfortunately doesn't work.
But could you go down by 5s from 2916 to 1296?
Well, how do you go backwards by 5? What rule are we going to use to go backwards by 5?
We can't.
So what are the rules? This is the rule that tells you how you go backwards. What does this rule tell you?
It tells you you can go forward by 5.
You can go forward by 5 only. So
But then we can
backwards
only
is
do
higher.
that when it is in the set. I mean, we don't know if this is in the set.
Right, but what do we know is in the set?
2916.
2916.
So maybe we could go, because we know that 1296 squared, whatever that is going to end in a 6.
It's 1679616.
And we ended a 6 here.
Uh-huh.
So this is a multiple of 10 difference, or
Okay.
more importantly, a multiple of 5 difference.
All right.
So we
you
can go up by 5s.
You can go up, then go back down with the square root.
It's gonna take a long time, right? If we were writing the numbers
Yeah.
down, but we don't have to write them down. We know we can go from here to here.
And then you just can go back to 1296.
And now we can go back to 1296.
And get a
36
6.
and then 6.
Okay, and that gets us. So now we have this interesting sequence 2, 7, 12, 17 going on forever.
We also have
We also have something starting with a 6. And where does this one go?
So 6, 11, 16, which means we can square root this, and we actually know we have 4.
Now we have 4, and where does 4 go to next?
It goes to 9.
And then to 14. And then so we have a 4 now.
And then we know we have a 3, so we have a 3, 8.
13.
So we have 1 mod 6, 2 mod 6, 3 mod 6, 4 mod 6, but no numbers 5 mod 6.
Okay.
So I guess
So
those are the numbers that aren't
So
in the
positive
set.
integers that aren't in S are numbers that are 5 mod 6 or 0 mod 6.
Mod 5.
Mod 5.
Okay. So what numbers are not in the set?
So multiples of 5.
So 5.
Try again.
Or numbers that are 0 mod 5.
Okay, keep trying.
Are we actually doing mod 6 here?
No?
Because we have 1 mod 5, we have 2 mod 5, we have 3 mod 5, and we have 4 mod 5.
Be careful.
These numbers are of the form 4 mod 5. 0 is a multiple of 5.
Okay. So let me stop being less. You are correct. The numbers 5, 10, 15, 20, etc. are not in the set. But that is not a complete list.
But we
of
also know
numbers.
the number 1 is not in this set.
Aha. You do not have all of the positive integers that are 1 mod 5. Why not?
Because
Because
we
1
proved
doesn't
that
work.
1 is not.
Yeah, so you can't forget. It's not just these numbers. Sure, there are infinitely many of these, but there's actually one more. Meaning instead of infinity, how many are missing?
Infinity plus 1.
Which is infinite.
So, but yeah, so it's important to note that 1, this is the smallest number that's 2 mod 5, smallest number is 3 mod 5, smallest number is 4 mod 5, but 6 is different.
Yeah.
I mean, it is what?
It's not the smallest number that's 1 mod 5.
Right, so in addition to the multiples of 5, also
one.
1 is not in the set.
Yep.
So this is a very cool problem, very challenging, but you can see that it's accessible,
It is.
right?
Yeah.
So what were some of the math ideas that went into this problem?
Definitely use modular arithmetic.
Modular arithmetic.
It's
Yeah.
like not really a math idea, but sort of like logic based. Just like following the steps, sort of how you were allowed to.
Yeah, and there were a lot of things that we noticed, like you could go forwards with these rules, but it was harder to go backwards. You definitely could not count down by 5, you could count up by 5. The way to go backwards was using the square root idea, and so we found some pretty neat stuff.
Yeah.
Anyway, this is cool. It's a good problem. Good work this morning, guys.